I wonder what the derivative of e to the x is. Let's find out. We're going to use this process. Again, not a polynomial, this one's exponential. So e to the x is our function. F of x plus h would be e to the x plus h. And just because I know, I almost said we know, because I know where this is going, I've done this before, I'm going to go ahead and simplify that a little bit more into e to the x times e to the h, based on the properties of multiplying with the like base. Okay, so let's take this idea, let's bring it over here. We're going to work through some things, some very obscure things that are going to pop out in the process, but we'll deal with it. So, blue pen, there you are. Don't run away from me, blue pen. The limit as h approaches 0 of f of x plus h, which is this, or this, I'm going to go with this one, e to the x, e to the h, minus f of x, which is e to the x, all divided by h. Okay, can't plug in 0 for h, that's just wrong, don't do it, I tried, it's not worth it. And I'm going to bring my work over here, as I did on the previous problem. Let's look and see what we can do with this. I noticed that there's an e to the x in this term, and this term is e to the x. Let's factor e to the x out, like a greatest common factor. So we have the limit as h approaches 0 of e to the x, and then e to the h minus 1. And that's over h. And at this point, you might say, well, I have no idea where this is going, and I don't know what I'm going to do. Well, there's something really cool, and if you're following along with the notes, it's at the top of the notes, and it is this. Check this out. I'm going to write it in red over here on the side. It says the limit as x approaches 0 of 1 plus x to the 1 over x is equal to e. Okay? So this is a thing. This is where e comes from. I'm going to change a couple things because you may not know to do this, and I didn't know to do it the first time I saw it either. Let me get in camera here, in and out. I didn't know to do this the first time I saw it either. A lot of math, a lot of trying to figure these things out. It's just experimentation. And this problem isn't something you'll be expected to know how to do. Don't turn the video off. But it is something that you would be expected to do in the future in different careers and different types of things. That process of thinking is good for you. So let's proceed. Just for the sake of where this is going, I'm going to take this, and instead of using x, I'm going to use h, because here's where I'm really going with this. I want to replace this e to the h. Trust me on this one. So limit as h approaches 0 of 1 plus h, 1 over h, is equal to e. Okay, I didn't do anything different. I just said, you know what, instead of using x, let's use h, because you can do whatever variable you want with that, right? If you ignored the limit, and we wanted to solve this, like if you were going to somehow just start solving this for whatever, you could raise it to the h power. So I would have e to the h, and it would cancel out this 1 over h. You're raising it to the reciprocal power. It's like if this was a square root, it'd be 1/2, you'd raise it to the second power. And that would give me 1 plus h. And this works. Now, I did just sort of drop the limit off, but this is true for this, which is where the limit as h approaches 0. So let me rephrase everything I just said. This is a thing when h is approaching 0. This is an extension of that where h is approaching 0. So I'm going to say that this is true for small values of h. For values of h that are approaching 0. So again, we went from here to here by saying, I really want to deal with h. Why? I'm going to take care of him. Why? You'll see why in a minute. And then I looked at this and said, ignore the limit. This and this are equivalent. Raise it to the h power on both sides. And they're both going to be true if h is approaching 0. So for small values of h. So considering the fact that h is approaching 0, I can replace this e to the h with 1 plus h. E to the h is 1 plus h. So here we go. Equals the limit as h approaches 0, e to the x, 1 plus h minus 1. You can see where this is going now. It's about to get real fun. About to get really easy, actually. 1 plus h minus 1 is, well, h. So we have the limit as h approaches 0 of e to the x times h over h. I see it, you see it, we both see it. Let's do it. We have the limit as h approaches 0 of e to the x. Well, at this point, I can plug in a 0 for h because I have no h's, so I'm just going to go on with it and be like, well, you know what? H approaches 0, so nope, e to the x. the derivative of e to the x is e to the x. It is its own derivative. Isn't that neat? Yes, it is. And here's what that means. The slope at any point of the graph of e to the x is equal to the value of e to the x. It's neat.